All right, for this next part, we are going to rewrite our original ionic compound from part A. So you've been writing it several times. It's also in the table if you need to go back and look. And so for our demonstration purposes here, my original ionic compound is Ga2O3. We're going to write and balance the decomposition reaction of your original ionic compound from part A. So this is what a basic decomposition reaction looks like. So there's only one compound, and the only thing it can do is decompose or break apart into its individual pieces. So I'm going to break my compound, gallium oxide, and break it apart into just gallium and just oxygen, and they're going to be by themselves. The tricky part for decomposition reactions is that when they break apart, these little numbers don't go with them. We're going to balance those at the end. So let me get started and then I'll explain what these diatomics are. So Ga2O3 is going to decompose or break apart into its pieces, Ga plus O, just the elements that make up that compound. Now, if one of your elements that's alone is one of these diatomic elements, these don't exist in nature by themselves, and only these 7 elements will need a little 2 after it in your reaction. So whenever you break them apart, don't put any numbers, just put the elements. Then you're going to go find each one on this list. So Ga was not on this list, so it does not get any number, but oxygen was on this list, so it gets a little 2. And then after you write this decomposition reaction, the only thing you can do now to balance it is put the big coefficients in front. So when we do this on our chart, we'll draw our chart. So we have gallium and oxygen. On this side, right now we have 2 galliums and 3 oxygens. And on the product side, right now I have 1 gallium and 2 oxygens. So I'm going to do the oxygens first, just from experience, but really you can do these in any order. So 3 and 2, there's no whole number I can multiply this right side by to equal 3. So I have to figure out what is a number that both 2 and 3 can equal so that we can get these to balance. So I'm going to make them equal to 6. So I'm going to multiply this side by 2 to equal 6, and I'm going to multiply this side by 3 to equal 6. So the numbers I wrote in the blanks here in these lines are the big numbers that I need to go back and write in my reaction. So now I have 6 oxygens on both sides. However, when I put this big 2 in front, 2 times 2, I now have 4 galliums on the reactant side. So 1 times what equals 4? A 4. So I'm going to put a big 4 in front of gallium. And so now you can do your part on your decomposition reaction.